Okay, thanks everyone for being here. It's a pleasure to be presenting in this conference for the first time. Maybe before we get started, and just to get a sense of who I'm speaking to, let's have a show of hands. How many of you in the audience are data scientists? Okay, that's most of the people. How many of you are engineers, like machine learning engineers or on the engineering? Okay. So another important question, how many of you are Quora users? Okay, so I'm going to be talking about things that relate to kind of like the intersection of data science and engineering. I'm not going to be talking about how we organize and we define those two teams and how they interact together, although I've talked about that in many occasions, and you can read some of my answers on Quora. But today I'm going to be focusing on how do we use machine learning at Quora to get knowledge out of the text that we have. So before I get into that, it's probably good to understand how do we think of ourselves at Quora. And I think some people simplify Quora to saying, oh, it's a Q&A site. And that's for us, I mean, it's true that we are based on the Q&A paradigm, but really that's just a tactical issue. How we really think of ourselves is, and this is our mission, a site and a company that it's really targeting to grow and share the world's knowledge. And there's many ways that you can do that, and you can think of maybe the closest example, Wikipedia, deciding to do that following the paradigm of the encyclopedia, right? You can grow the world's knowledge and share it using the encyclopedic approach. We think that the question and answer approach is actually better nowadays to grow and share the world's knowledge. But the basic idea is we are in this world to basically grow the knowledge and to share it. And we do have, of course, millions of questions and answers. We do have millions of users, and we have thousands of topics that we will use in different ways to share that knowledge and to grow that knowledge. Because of that, there's three different aspects or dimensions that are really essential to us and we care a lot in everything we do, and especially on the algorithms that I'll be getting into later. Those three things are relevance, quality, and demand. Relevance basically means we want to make sure that we get the right knowledge to the right people, and that's really important because that's one thing that makes basically knowledge shareable, and it also makes it grow, right? Because we want to get the right question to the right person so that person can answer it. We also want to get the right answer to the right people so they get interested and they generate more knowledge. Quality is really important and something that sets us apart from many other Q&A sites, and I think that's an important thing that relates to our mission again. Because knowledge means, by definition, you have to have a notion of quality, right? Knowledge without quality, it's basically noise. It's not knowledge. It's just information that produces noise. So we need to care about the quality of what's being written in our site, and we'll talk about that. And the last thing is demand. So we also care about what is the knowledge that most people want to know about, right? So you could write a lot of things about a very obscure, very narrow topic that nobody cares about, and you're really wasting a lot of energies of the person who's actually generating that knowledge. However, there might be some knowledge that a lot of people want to know about and nobody's writing about, and that's really important because we care, of course, because of the, also related to the relevance, we care about sending the right knowledge to the right people. We also care to understand what's the knowledge that people want to know about. Okay, so then to summarize sort of like what is our goal is given the text in a question or an answer, we want to understand a number of things. We want to understand the quality of the answer or the question. We understand who will be interested in that, how important it is, what is it about, what it relates to. All these things are going to matter in terms of optimizing those three dimensions that I talked about. Okay, so the truth is we have a lot of text, but we also have a lot of other data that we can combine with the text in our algorithms. So speaking of text, and I'm going to go through this very quickly, but all of the next slides you can actually refer to the data blog on Quora and read more about it. This is an example of how much information we can find in the text and we can find in our textual data. In this case, when a data scientist in our team was mapping the discussion over time, looking at the text and looking basically at what are the relevant key concepts, how they relate to each other over time. And you can see things like on this graph over here, where you have a focus term like Obama, and there's different things like election, Syria, immigration, and so on, and how those terms over time change, and how we can track topical interest in our population. And this relates to demand, but topical demand, right? For example, this is just an example. It's a very long blog post that you can read if you're interested in how we extract knowledge from data. But again, there's a lot of information that it's not only text, right? If you actually look at our interface, and this is an answer from by Andrew Ng, you'll see that there's a ton of stuff. Like there's the topic, there's the question, there's the user, there's things related to the user, there's the answer itself, there are actions on the answers, things that users can do, like upvote, downvote, comments, all of that. So we have text and all those things around text that we can infer a lot of information from. So this is a graph that I usually use to explain the complexity of our data ecosystem. So basically we have questions and answers, and that's the Q&A paradigm, but we have a lot of other stuff, right? So we have users, obviously, that interact with those questions and answers. So users can do different actions. They can upvote or downvote. They can want an answer. They can want a question. They can re-ask a question. They can answer a question. And we also have an overlay of social network. So users can do things to other users, like they can follow, they can endorse on a topic, and so on. And speaking of topics, we also have a topical network that is overlaid on top of all of that, because questions have topics, but users also are endorsed on topics or write on topics, right? So basically, we have kind of like 3 different overlays of data relations. There's the textual one, then there's the user one, and then there's the topical one. And all of those interact in this way, and they're taken into account in the different algorithms. Because of that, we can study complex propagation effects in any of the networks. So in this blog post, Shankar was talking about how upvotes, which is one of the actions, just one of the actions that users can do on the answers, actually propagate in the network. And again, this is a very long post that you can refer to, where you can see how the upvotes propagate on that overlay and how the different connections, including the social ones, affect the propagation effects on the upvotes. On the topical overlay, we can also study like how do topics relate, how relevant they are, what's the hierarchy that we have between the topics, how different answers and questions and users relate through topics. So this is another blog post that you can find on our data blog. And finally, we can also look at usage patterns. So this is not one of the main overlays that we have, as I explained right now, but just to give you another sense of other things that we can look at. Here in particular, we were interested in understanding what are the usage patterns and what they tell us about people. And this is a very interesting blog post where you'll find things that might seem obvious, like what is the day of the week where people actually search for questions related to hangover, or for going out, or being late to school. So there's like different things that obviously over time and different patterns of usage. And that's also an example of sort of like site information that we can use. Okay, so I'm going to move now to talk about different machine learning applications. Is there any questions so far? Anything that I can clarify? No? Okay.
I have one.
Yeah.
So When someone posts a question, right, why do you not crawl and find the answer if available on the web?
Okay, so the question is, why don't we extract information available already on the web? And I think that's it's a good question. It's important to remember that the main part of our mission is to grow the world's knowledge, right? So that's very different from Google's mission, which is to organize the world's knowledge. And by organize, I mean whatever is already available on the web. Our goal is, and our hypothesis is, there's a lot of knowledge that's still not digitalized and still not on the web. What we want to get is, that knowledge that is in your head and put it on the web. So that's part of our mission, and it's kind of different from going out there and grabbing stuff that is already available. Of course, people, in order to generate knowledge, they might refer to things that are already on the web, and they do that all the time, right? They synthesize different sources, they put them together, they answer a question. But that's different. In doing so, they are generating new knowledge. They're not really just referring to something that already exists. As a matter of fact, we don't like answers that are just a link, right? It's like, hey, you can find this here. Well, if you can find it here, then you're not generating new knowledge.
So do you extract information from Wikipedia kind of site?
No. Okay, so one of the dimensions that I was talking about was quality. How do we understand quality, and what does it mean to understand quality? So I'm going to talk about this through a couple of examples. One of them is answer ranking. So answer ranking is an interesting example from a data perspective and from a machine learning perspective of how you can turn a real world problem into something that you can optimize through a machine learning algorithm. The question we faced, and this is explained here in the goal, is given a question and n answers that we have, how do we rank them according to quality? And of course, I think the key question here is like, what does quality mean, right? Because you can define quality in so many different ways. Fortunately, if you ask people that work on the product, so that's what we did, the machine learning engineers and data scientists talked to the product people, including the CEO, and said, hey, how do we define a Quora answer, a good Quora answer? What does a quality answer in Quora mean? Interestingly, we have that in the site. So we have a policy and we have an answer that says, how do we identify a good quality answer on Quora? So when we read that definition, we see things like truthful, reusable, it provides explanations, it has references, it's well formatted, it doesn't have spelling mistakes, so on and so forth, right? So you can actually list all the qualities of, all the properties of a high quality answer. So what we did then is basically turn all those qualities into features that we optimize in a machine learning algorithm, right? So we have features that relate to the text quality itself, we have interaction features that the users actually support or don't support that answer. We have user features, for example. It's really important to understand how much the person that wrote the answer is an expert in that given topic or that given field, and so on. So the basic idea here is you don't have to come up with a unique definition of quality. You need to understand what are the different dimensions that play into that definition, and then optimize your machine learning model to that.
Question.
Yeah.
How do you deal with the bias? Because if you rank it higher because it's higher quality, then you may get more upvote. If you're using upvote as one of the features to evaluate quality.
Yeah, I mean, if you rank it higher. Sorry, oh yeah, I'll repeat the question. The question is, there are some interaction features that will receive some form of feedback, because if you rank the answers higher, they'll get more interaction, so they might get more upvotes. That's mostly true, but it's not entirely true. So the fact that you rank an answer higher, it's going to generate more feedback from the user, but that feedback doesn't necessarily need to be positive. That's one of them, right? So it will most likely get more upvotes, but it's also subject to getting more downvotes and other kinds of reactions. And there's other things that actually the model has learned to value more than some things. And some of them even relate to the timeliness, right? So we also might take into account, I'm not saying we do or we don't, but we might take into account like how recently those upvotes came in or they didn't come in. And the reason for that, obviously, the best answer to a question might also depend on, was that answer given 10 years ago or is that answer recent, and how does that pan in? So all these things are going to matter, and actually the system is pretty dynamic, so you'll see that things come in and out, and it's very likely that some things that are pretty new, they'll be ranked higher than things that were higher before. Yes?
Sure, perfect. So you give a numeric score to quality, and how is that done? So there are features that I understand, but then
Yeah.
what is the target pattern for the algorithm?
Yeah, I mean, the bottom line is you need to train like any machine learning model. In this case, this is a ranking model, so it's a learning to rank approach. So you need to give it some positive and negative examples, or you need to give it some pairwise ranking examples, right? So that's the thing. You need to generate that training data, and there's different ways that you can do it. You can do it either through like ratings that you give in the lab, and experts can give that, or you can also use the feedback from some users in the product, or you can combine all these things. The bottom line is you need to have that target, that training in order to generate this ranking. But it's not any different than any other learning to rank approach. Okay, I'm going to move on. Other things that we do in the context of understanding quality are related to the notion of moderation, right? Because obviously, if you want to keep the quality high, you need to do things like make sure that there's no spam, there's no harassment, there's no use of, say, bad language. There's a number of things that you need to understand and filter out of the site, and that's not a trivial problem, right? I mean, spam is probably the easiest one, but all the other ones are kind of hard to understand. So how do we do that? You might think ideally you could hire a lot of people and have them all sort of like basically manually check that every question and every answer doesn't fall in any of those different categories, right? That is very expensive and doesn't scale. So what we need to do is this hybrid model of machine learning plus manual curation. So how that works is through something we call the moderation queues. So the idea is you have a machine learning model that, let's take the case of spam because it's the easiest one to understand. You have a machine learning model that decides this is spam and just takes it away. There's other things that are clearly not spam, so they're taken away, or they go into the side. And then there's the gray area. There are things that, I don't know, this could be spam, I'm not sure. The algorithm is never going to be 100% perfect. So for those things in the gray area, we route them to the moderation queue. We don't only route them in a kind of like first in, first out queue. We actually have a priority. There are things that are more important to understand quickly if they're high quality or not, because we anticipate they're going to be very important. So we feed them into a moderation queue that has some notion of priority, and then we have humans going into that moderation queue and looking at the next thing they need to look and say, oh yeah, no, this is spam, so remove it. So that's the thing we do for, again, we have different queues with different kind of people that have specialized on different aspects like spam, harassment, and so on and so forth. And we have all the different machine learning algorithms that are tuned in order to feed into those queues.
Is that how you manage a duplicate or similar question?
No, I'll get into that later. The question was about if that's how we manage duplicate or similar questions. Okay, so the next thing is we've seen a couple of examples how we understand quality. How do we understand relevance, right? And by relevance means, like, is this interesting for that person? Typical example of this is feed. When you go to your homepage at Quora or you open the app on your mobile, you're going to see your feed, which is basically what we think is the best stuff in Quora for you. And what does that mean? I mean, what's the goal? The goal is actually to present the most interesting stories for a user at a given time. And interestingness is a loaded word also. Interestingness means topical relevance plus social relevance plus timeliness. All that needs to play in. And stories, importantly, means the combination of both answers and questions. So we're trying to optimize the reader experience, but remember, our goal was to grow the world's knowledge. So we also want to get those questions in there in your face if we feel like you can really answer those questions. So the idea here, how do you do this? The machine learning approach is a personalized learning to rank. There are many challenges that we need to face here, like there's many thousands, if not millions sometimes, of candidate stories. We need to make sure that that's ranked in real time because we care a lot about timeliness, as I said before. And again, we optimize for relevance. We want to make sure that the thing that is up there is the most interesting for that particular user. So how do we do that? So we do that, again, looking at all the features that we have from the stories, that is questions and answers, and we feed that into our learning to rank algorithm. So feature engineering, I've mentioned that already in the answer ranking example. It's a key issue to most of our models, and I think it's a key issue to machine learning, period. And I know there's some discussion back and forth with, for example, the deep learning practitioners of whether feature engineering is alive or is dead. And it was funny that I went to Montreal a month ago, and I had a presentation just after Joshua Bengio was talking about all the deep learning approaches, and I was there on stage talking about how important feature engineering is. And I think it is important. And if you're interested more in this topic, there's an answer I have on Quora about will deep learning replace all the other models, where I say no, and I refer to feature engineering as one of the reasons it won't. But anyway, feature engineering is very important. In the case of feed ranking, we have a different number of features that relate to the user, the story, the interactions between the user and the story, and all of those goes into the personalized learning to rank approach. Now, what kind of models can you use to train a personalized learning to rank approach? This is also a long discussion, but the idea is start as simple as you can. A simple linear classifier like logistic regression might be good enough for you, and you can build a personalized learning to rank approach using just a point-wise classifier like logistic regression. Then you can go into more complex models, so to speak, and you can learn known linear interactions between your features, and decision trees are really good for that. And obviously that takes you to the next level, which is tree ensembles like random forest and gradient boosted decision trees. And you can go beyond that and then go to like what is proper learning to rank approaches, like for example lambda mart, which is an extension of gradient boosted decision trees, but includes, you can optimize the loss function to a ranking metric. So we've tried all of those, and basically we just go with whatever works best. The good thing about having a nice infrastructure is that you really are not married to a particular model. You basically can try all of them, say, okay, what's the simplest one that I can use that gives me the best results? And the simplest one is important because you want to be able to innovate and to grow and experiment on that model as much as possible. But there's some times that you need to go to a more complex one. There's no way around it because it's going to work better, simply. And we do have C++ training code that we've implemented ourselves, but we also based a lot of the work that we do on third-party libraries, especially on the prototyping, sort of like experimentation phase. Okay, and my last example of relevance, it's email digest. I just included this one for this presentation because every time that I've talked about things we do at Quora, there's somebody after the talk said, hey, for me, the most impressive thing is when you send me the email and you haven't talked about this. I say, okay, I'm going to talk about email digest. So email digest, the truth is, it's very similar to the feed example, although it has some differences, right? But the goal is still to present the most interesting, and in this case, answers and we limit the subset to 10. And also, a second goal is to optimize the number of emails and the time those emails are sent to each person. So it's another personalized learning to rank approach, but the difference here is we only rank answers, no questions. And we can do offline ranking as opposed to what we were doing in feed, which needs to be real time. We can do offline. And we need to worry about saturation in the channel, meaning like we can't send you too many emails, and we need to understand when are you most likely to be interested in that email versus like just sending you tons of emails. Okay, and ask to answer, that's another example of relevance, which I think it's pretty unique to Quora. There's a blog post that we wrote about this a couple months ago, so you can see more details there. A2A, or ask to answer, is this idea of we want to make sure that whenever we have a question, the system understands who are the people that we have on Quora that are most likely to write a good answer to that question. And then once we know that, we can suggest whoever wrote the question, like, hey, this is a very good question. You should ask that person over there because we know that that person can give you a good answer. There's the A2A, the manual approach. The system itself also sends those requests on its own. So the idea is, given a question and a viewer, we want to rank all the other users on how well suited they are. This is a kind of like complicated problem formulation because you have content, text, users sort of like kind of like mixed together. Well suited is also complex because it has a combination of the likelihood of whoever is viewing that rank to send the request, plus the likelihood that if the receiver gets that request, they will provide a good answer, right? So all of that goes into the formulation of the problem. It's really an extension of CTR prediction because you care both about the probability of the viewer sending the request, but also the user responding to it. It's kind of similar to the, there's some literature on sort of like these bidirectional recommender systems. A typical example of this is all the dating sites where you have to recommend a connection that you feel like the other end, once it's made, will also respond positively. So this idea of connecting people where both ends need to actually respond positively, there's some research on that. Okay, so I think I'm going to skip this because I'm going to run out of time, and I'm going to move directly to other examples. We also do recommendations on different things that help us sort of build a better graph, right? When I talked about the different overlays that we have and different data relations that we have, I talked about users connecting to users, users connecting to topics, and so on and so forth. Those things are really important, but we need to actually push our users and we need to push the community in order to grow those relations. So one way we do that is by recommending those connections, right? So if you're a user, especially if you're a new user, we want to make sure that you connect to topics. So we'll give you recommendations of other topics that you should follow, and those recommendations are going to be based on anything else. It's going to be based on other topics you follow, on users you follow. Obviously, if you start following a lot of users that are interested in machine learning, we'll say, hey, do you want to follow the topic machine learning? User interactions and topic-related features. In a similar way, we'll recommend you users, and we'll use anything else in order to recommend you users, including, and this is the inverse, the topics that you follow, right? If you're following machine learning and data science and related topics, we'll look for the good users that relate to that area, and we'll recommend you to follow those users. And finally, trending topics. So this relates to this notion of personalized timeliness. There's topics that come and go and appear all of a sudden, and we feel like you might be interested on. And in this case, there's this notion of we want to recommend a topic, but this topic did not exist an hour ago, right? So it has its own challenges, but we basically apply this notion of there's going to be different trendiness coefficients. The global trendiness, like how much that trends overall, the social trendiness, how much that trends in your social group, and your user interest, and so on and so forth. Okay, so we've talked about understanding quality, understanding relevance, and making all sorts of personalized recommendations. Now we get to understanding relations. In the text and in all the content that we have, there's a lot of relations that we need to understand. Like somebody was asking me about similar duplicate questions. I'll talk about that in a second. One of them is we want to understand what's the relation between a question and a topic, and that's what we call topic labeling. This is a very interesting and I would say fascinating problem in our case, because we have like a huge and we think very good topic ontology that goes all the way from like very broad topics like science to like super specific topics like tennis courts in Mountain View, right? And all of those things are available. And once a question comes in, we need to have an automatic machine learned algorithm that says, hey, given this question, these are the topics that should go with that question. It's a hard problem because a question by definition is going to have like very few words. So we need to sort of like apply all the knowledge that we have from like the few words that are available in that question to infer what are going to be the good topics. That said, right now, I mean, I think the accuracy is pretty good, but we still rely on users also entering topics and correcting sometimes the topic labeler because the topic labeler made a mistake. So the user will get a notification, hey, these are the topics we think are the good ones. Do you want to add or remove some of them? Related questions. So given interest in one question, what is the next thing we should recommend you? And this is kind of like a combination of structure or relation in the content, but also a form of relevance, so to speak. And the reason for that is because whenever you hear any algorithm that talks about finding similars or finding related things, people usually the naive approach is like, okay, let's base this algorithm purely on the content, right? It's like I find similar songs, like, okay, what's the beat, what's the harmony, who sings that song, let's find something similar. The truth is, in practical applications, the notion of similarity or relatedness, and I'm speaking from my experience here, but also from Netflix and other friends that I have in many companies, is that it kind of like, it's confounded with the notion of interestingness. As a matter of fact, if you recommend two things that are extremely similar, chances are the person is not going to be interested in it. Like, yeah, okay, you're recommending me the same question again. I already know the answer to that question. I want something that is related, but it's also interesting. And you can optimize your algorithm to that. And you need to take those things into account, like co-visits, who visited this and also visited that, which is something different from the purely textual or topic similarity. Duplicate questions is the extreme case of related questions. And actually, we don't like duplicate questions. We love related questions. We don't like duplicate questions. So that's an interesting thing. Why don't we like duplicate questions? Because duplicate questions are basically diverting the energy in the system. If you have the same people answering over and over again the same question, or saying, well, this is almost exactly the same thing as I answered before, or you have 10 answers on this question, 10 answers on this other question, which basically are the same, you don't want that to happen. So in this case, the solution is we have a binary classifier that is trained with label data, and it's similar to the notion of related questions, but in this case, it's purely attempting to use label data on things that are duplicates, and we know that they're duplicates. How do we know that they're duplicates? Well, because we've been through the process before. We actually have a feature in our site which is called merging questions. Users and moderators and ourselves can actually merge questions when we decide that they're the same. So that's a good training set to understand like what is things that were duplicates in the past, and we use that to train using things like vector space models and usage-based features. Okay, user trust is another form of relation that we have in our network, and that actually this inputs into many of the other algorithms that we have. We want to understand, given a user, how much can we trust that user in a given topic? So we have this notion of topical trust or trustworthiness. We take into account how many answers the user had written on the topics, but also we want to understand what was the quality of those answers. So we want to take into account how many upvotes and downvotes those answers received. Endorsements, it's another feature we have in the site. Users receive endorsements on topics. So this is kind of like PageRank approach, where you have a network of connections and the trust propagates, but propagates in a topical sense. So if you have experts on machine learning endorsing or upvoting other experts on machine learning, that's going to propagate through the network. Okay, so that was all about different kinds of applications on how to extract knowledge from text and the other relations that we have in our data set. What are the models that we use? I don't have, obviously, time to go into all of those, but I've mentioned several in different contexts. But this is I would say, incomplete list, but there's like most of the things that we use currently in production that go all the way from simple logistic regressions or elastic nets to more complex deep neural networks, matrix factorization, and other collaborative filtering approaches. All of this fit into different things that I just explained. Okay, so with that, my conclusions is Quora not only has a lot of text, but we also have complex data relations that actually help us understand more what's in that text and how much quality there is and how it is related to other things and so on. And we need to have algorithms that understand that complexity and are able to optimize the dimensions that I talked about: quality, relevance, and demand. And machine learning is definitely one of the keys to our success, and we have a big part of our technical engineering and data science team working on machine learning related approaches, as you can see from what I've just presented. But we also have many problems that are still unsolved, right? If you think about the things that I mentioned, we're still leaving a lot of things out that we could definitely do a lot more using machine learning, NLP, in order to extract even more knowledge and more relations from that text. So I don't know if there's time for questions. If they're not, I'll be here during lunch, and you can also ask me on Quora, because I'm like constantly answering questions on Quora. Thank you.